What's up, everybody? My name is Harpreet Sahota. I'm a hacker in residence at Voxel 51. For the next 2 weeks, I'm going to be talking about papers that are going to be presented at CVPR 2024. Let's get into today's paper. The paper we're going to talk about today is called Eyes Wide Shut, Exploring the Visual Shortcomings of Multimodal LLMs. The whole point of this paper is trying to understand why the most advanced multimodal models like Gemini, GPT-4 Vision, and even Lava, all models that can handle text and images, sometimes fail when they're asked simple questions about an image. Before getting into their proposed methodology, I want to talk about the problems that are plaguing the current generation of multimodal language models. As powerful as this current generation of multimodal models are, they still struggle. For example, you can see here, this model is struggling. This right here is GPT-4 Vision. It's struggling when asked a simple question. Is the door of the cab truck open? You can see here, it's clearly open, but the model is saying, nope, it's not open. Here, we're just simply asking how many eyes does the animal have? Here we can see 2, but the model is saying 1. So on and so forth. You can see that these models tend to struggle. But why is it? Why is that these models struggle? It turns out that the current generation of multimodal models use CLIP. And so CLIP is pairing images with a text description, and it's trying to create a joint understanding of both of them. But CLIP has a significant flaw. This is called blind pairs. And so a blind pair in CLIP are sets of images that CLIP sees as being very similar when they're actually quite different from each other. So imagine that we have 2 images, one of a cat and one of a dog. Now, if CLIP is considering these images similar because they both have furry animals, it might treat them as nearly identical, even though cats and dogs are very different. What ends up happening is a confusion of the model, which is going to lead to a poor visual representation. So this means when the multimodal model is trying to answer a question about these images, it's going to confuse details or provide incorrect answers because it doesn't understand the visual differences. And so these blind pairs leads to a ton of issues. For example, we end up with poor accuracy. So these models end up giving incorrect answers because they're misidentifying objects or even misunderstanding their positions in the image. Also, these issues can further compound, which means that we might end up with hallucinations from the model where they're making up an explanation for an incorrect answer. This could be sometimes misleading. So the first thing the researchers did was actually identify 9 visual patterns that CLIP vision encoders often end up misinterpreting. These are, for example, orientation and direction, the presence of a specific feature, state and condition, the quantity and count, color and appearance, position and relational context, structural and physical characteristics, text, and viewpoint and perspective. With an understanding of these shortcomings, they create a benchmark called the MMVP benchmark. And this MMVP-VLM benchmark is designed to test and evaluate the visual understanding and capabilities of these multimodal large language models. This benchmark includes questions and options that are going to transform abstract visual patterns in images into clear language-based descriptors that are easier to categorize and analyze. And from here, they come up with a proposed solution. The proposed solution is called a mixture of features. And this is meant to address the problem of the CLIP blind pairs. The method here is trying to improve the visual understanding of multimodal models by integrating better visual representations from another model called Dino V2. So the current methods use CLIP. So this is the visual part of these models. It's trying to understand images by comparing them to text descriptions. However, it can get confused by images that it thinks are similar. So they improve upon this using something called a mixture of features, which includes a additive MOF. This method is combining the features from CLIP with features from Dino V2, which improves how the model is going to see images, but it's going to reduce its ability to follow instructions. And so to improve upon that, they use something called the interleaved MOF. And so this mixes the features from CLIP and Dino V2 to keep the model good at understanding images and following instructions. They propose that this method is better because we get better image understanding because we're using features from Dino V2. The model is better at recognizing image details. We also get balance of skills from the interleaved MOF, which helps the model stay good at understanding images and following text instructions. We also end up with fewer errors because we're reducing the mistakes from the current method's confusion between dissimilar images. If you want to learn more about this paper, check out the GitHub. I'll link it in the description below. They've got the code for training as well as some interesting benchmarks and results that you can go ahead and check out. That's it for this one. I'll see you tomorrow.